Hello friends, welcome to Learner's Planet. Friends, this is our third session for probability. In the previous session, we discussed good number of problems based on dice and playing cards. In this session, we'll be taking multiple choice questions. And I would recommend you to attend the previous session and all the sessions of permutation and combinations as well. So let's begin the session. Now friends, let's take this question. Now here we have to find out the probability of getting a number between 1 and 100 which is divisible by 1 and itself only, right? That means precisely we have to find out the probability of a prime number, right? So from 1 to 100 we are having total 98 numbers. Now out of these 98 numbers there are 25 prime numbers, right? We begin with 2 and end up with 97, so in all there will be 25 prime number. Out of 25 prime number, 4 are one digit prime number, 2, 3, 5 and 7, and the remaining 21 are two digit prime numbers, right? So in all we are having 25 prime numbers. So the probability of getting a number that is divisible by 1 and itself is 25 by 98. Okay. Now friends, let's see this question. The probability that a leap year selected at random will contain 53 Sundays. See, in all, in a complete year of 365 days, there are 52 weeks that are completed weeks. That means 52 Sundays are there plus 1 day. That means precisely 52 into 7 is 364 days, right? So in a normal year, we have one extra day after complete 52 weeks, right? So in a leap year, we have two extra days after 52 weeks, right? Now these 2 days, right, may make the various combinations, maybe Monday, Tuesday, Tuesday, Wednesday, Wednesday, Thursday, Thursday, Friday, Friday, Saturday, Saturday and Sunday and Monday, right? So we are having 1, 2, 3, 4, 5, 6, 7 combinations in all. And out of these 7 combinations, we are having Sunday at 2 places, that is Saturday, Sunday and Sunday, Monday, right? So if the 2 days, and obviously 2 days will make these many combinations only, so we are getting Sunday for 2 times, so the probability of getting 53 Sundays is 2 by 7 because 52 Sundays are already there in 364 days, right? So in these 2 extra days there are 2 ways of getting Sundays. Okay, so it's 2 by 7. I hope you are clear. Now friends, let's discuss this question. A bag contains 5 red, 6 white and 7 black balls. 2 balls are drawn at random. What is the probability that both the balls are red or both of them are black, right? So in all, the total number of cases will be 6 plus 5, 11 plus 7, 11 plus 7, that is 18, right? So out of 18, we are drawing 2 balls, right? So in all, the combinations will be 18C2, right? Now, what we want, so these are the total number of cases. In the numerator, we'll be taking the favorable cases, right, in which we are interested. And now we are interested in both the balls are red or black, right? Red or black, right? So if both the balls are red, that means it's 5C2, or that's plus, both of them are black, right? So this is the total calculation. We just simplified. It's 5 into 4 plus 7 into 6 by 18 into 17. So it's 20 plus 42, 306, or we can say it's 62 by 306 or 31 by. Okay, so 31 by 153 is the correct answer. I hope you are clear. Now, 4 cards are drawn at a time from a pack of 52 playing cards. Find the probability of getting all the 4 cards of the same suit. Now total number of cases will be 52 C4 because we have to draw 4 cards out of 52. So we'll be getting these many combinations. Now what we want, all the 4 cards should be of the same suit. That means we are having 4 suits, that's diamond, hearts, clubs and spades. Now each suit is having 13 cards. So what we want, all the 4 should be of spade, or all the 4 should be of clubs, all the 4 should be of diamonds, or all the 4 should be of hearts, right? So this is what? So it's 4 times 13C4 by 52C4. Right? 4 factorial is getting cancelled from both the places. So this is the final calculation that we have to make, right? So it's 44 by 17 into 49. Yeah, in fact into this 5 will also be there. So 17 into 49 into 5, that's, I forgot this. So it's 44 by 4165, right? Now next is, from a well shuffled deck of 52 cards, 4 cards are drawn at random. What is the probability that all the cards drawn are of the same color? Now in all we are drawing 4 cards, so the total number of cases will be 52C4. Now all the cards should be of the same color. Now in cards we have 2 colors, that is red and black, right? Now 26 cards are of red color and 26 cards are of black color. So either 4 cards are of red color or they are of black color, right? So this is red, this is black. Okay, so it's 2 times 26C4. So 26 into 25 into 24 into 23 by 52 into 51 into 50 into 49, right? So it's 4 into 23 by 17 into 49. So that's 92 by 833. So I hope you are clear. Now the next question is, a bag contains 10 white and 15 black balls. What 2 balls are drawn at in succession without replacement. What is the probability that first is white and second is black, right? Now friends, what is the word mean without replacement? That we have already discussed, that when we are drawing the first ball is being drawn from the 25 balls, right? But after taking the first ball, we are not putting it back. That means the second ball which we are going to draw will be drawn from the 24 balls only, right? So let's take the first case. The first should be white, right? So there are 10 white balls out of 25, right? Now the first event and the second event, or we can say the first row and the second row, both the events are independent of each other, right? So whatever ball we are getting for the first time, it doesn't create any impact on the second row, right? So in second time we have total number of balls as 24 because we are not putting the ball back into the group. So in the second case I want a black ball, and now there are 15 black balls. So this will be the probability of getting the first is white and second is black, right? Be very clear about this term without replacement. I'm not putting the ball back into the group, right? So it's so it's 1 by 4, right? I hope you are clear. Now here a bag contains 5 white, 7 red, 8 black balls. If 4 balls are drawn one by one without replacement, find the probability of getting all the white balls. Now let's find it out. 8 plus 7, 15 plus 5, 20. So the first draw will be from the 20 balls, right? Because we are not making replacement over here, but in the first case we are having 20 balls and I have 5 white balls. The first ball will be drawn from 20 and we have 5 choices, right? Similarly, the second ball will be drawn from the 19 because we are not putting the ball back. Now in the second case I wish to draw white ball once again. Now I have 4 white balls because I have already drawn 1 white ball. So it's 4 by 19. Similarly 3 by 18 and 2 by 17, right? I wish to draw the 4 balls, so which I have drawn over here. So it's 1 by 19 into 51. So I hope you are clear. Or friends, else you can do like this also. Since you wish to draw 4 balls, we can say the total number of cases will be 20C4 and all the 4 balls should be white. So I just take 5C4. This is also one and the same thing, that's without replacement, right? Because every time we are getting one choice less for white ball. So if you open it, you'll be getting the same calculation as over here. Okay, so you can go this way or this way. Now here 2 balls are drawn from an urn containing 2 white, 3 red and 4 black balls, one by one without replacement. What is the probability that at least one ball is red? Now since we are taking out 2 balls and we have 3 red balls, so we have various cases. There are 2 ways of doing this problem. The first way, it's 2 plus 3, 5 plus 4, in all there are 9 balls, right? And we have to draw 2 balls, so its total number of cases will be 9C2, right? Now we have the combination of 2 balls where we want at least one ball to be red, right? So we can get the various combination, than one white, one red, or one black, one red, and other combinations as well, right? When we are getting 2 red balls, right? But that will be a bigger process or large lengthy process. What we can do, I do not take even a single red ball and get the probability. And what that will be, see, if I don't have to consider red balls, I am left with the 6 balls. That is 4 plus 2, 6 balls. So both the balls should be drawn from these 6 balls, right? So it's 6C2 by 9C2. So it's 6 into 5 by 9 into 8. So it's 5 by 12, right? Now 5 by 12 is the probability when not even a single ball we are getting is red, right? Now we want at least one ball to be red. That means in all the probability is 1. Now from the entire case, from all the cases, if we deduct the cases when we are not getting even a single ball to be red, so in the remaining cases we will be having at least one ball to be red, because we have deducted all the cases when not even a single ball is red, right? So this process will be a simpler one, where you don't have to make any sort of combinations, right? So what did we do actually? Out of 9 ball we have to draw 2 balls, and in the numerator the favorable cases which we took is not even a single ball is red. That means all the balls are either white or black, right? So we draw 2 balls from the 6 balls which are white and black, right? So this is the probability of getting balls to be white or black but not red, right? So we got 5 by 12. In all, the value of the probability, maximum value of the probability is 1. From 1 we deducted all the cases when not even a single ball is red. So in the remaining cases at least one ball will be red, right? So this at least you have to take care. Now friends, let's take this question. A bag contains 5 white, 7 red and 4 black balls. If 4 balls are drawn one by one with replacement, what is the probability that none is white? Now it's with replacement. That means you are drawing a ball, you are just seeing the color of it and you are putting it back in the group, right? That means whenever you are drawing a ball, you will be drawing from these 16 balls, right? 7 plus 5, 12 plus 4, 16 balls, right? The first ball will be drawn from the 16, the second will be from 16, the third will be from 16 and the fourth one will also be from 16, right? But none of the ball to be white, what we want is, right? So suppose we are drawing for the first time, so total number of cases will be 16, that is total choice available with us is 16, and out of this the ball should not be white, that means we are left with the 11 balls, right? So out of 16 we have 11 choice for the first time. Similarly, for the second time we have 11 choices out of 16 because whatever the ball we are drawing we are putting it back, right? So it's 11 by 16 into 11 by 16. The same thing will be there for the third time and the fourth time, right? Because every time we are just drawing the ball and putting it back in the group, right? So in all it's 11 by 16 raised to 4 when none of the ball is white. Okay. Now friends, again we have the case of at least. A bag contains 5 white, 7 red and 8 black balls. 4 balls are drawn one by one with replacement. Again we have with replacement. What is the probability that at least one is white? Now further what we can do is we just take all the cases when none of the ball is white and will deduct it from 1, right? And every time when we are drawing the ball we are putting it back in the group, right? So for the first time we have the choice 8 plus 7 15 plus 5 20 balls, right? Out of 20 balls I have to draw one ball and I have 50 choices because I'm not drawing white ball, right? So it's 15. So precisely it is 3 by 4, right? So the probability of drawing the first ball is that is non-white is 3 by 4. The second time the same, the third time the same and the fourth time the same. Why? Because we are not drawing white ball at all and every time when we are drawing the ball we are putting it back, right? So in all this is the probability, that's 3 by 4 raised to 4 is the probability when we are drawing 4 balls one by one with replacement and none of them is white, right? Now in all the total value of the probability is 1. From 1 if we deduct these many cases then in the remaining cases at least one ball will be white, right? So be very clear about it. You don't have to solve, you just have to look at the options if you are appearing for competitive exams. If the option allows you to put the answer in the same format, you go ahead, otherwise you just have to simplify it, right? So I hope you are clear. Now friends, let's see this question. Two cards are drawn from a well shuffled pack of 52 cards without replacement. What is the probability that one is red queen and other is a king of black color? Now that's two without replacement. Now we have to choose two cards from 52 cards. So in all the total possible cases will be 52 C2, right? Now one should be red queen and other should be black color. That means there are two possibilities. The first is red queen and the second is black king, or the first is black king or the second is red queen. Now we have two red queens, right? So we have to select one from that, and we have two black kings, so we have to select one from that. So it's 2C1 into 2C1 by 52C2, right? And it's already calculating without replacement. So it's 2 into 2 by 52 into 51 by 2, right? Okay. Now next question is, bag A contains 4 red and 5 black balls and bag B contains 3 red and 7 black balls. One ball is drawn from bag A and two from bag B. Find the probability that out of 3 balls drawn, 2 are black and 1 is red. Now there are two cases possible. From the first bag we are drawing one ball, and from the second bag we are drawing 2 balls. Now we have to draw 3 balls. Now the choice, the first case is, we are drawing black ball from the first bag and one black and one red from the second bag, right? Or we are drawing red ball from the first bag and two black balls from the second bag, right? So let's take first case. So in all there are 9 balls in the first bag. Out of this we have the choice that is black 5. Simultaneously we are drawing one black and one red ball from the second bag. So from the second bag, in all there are 10 balls. So 10 from 10 we have to draw 2. So one should be black and other should be red. So one is red and other is black. Or the second case is, from the first bag we are drawing red ball, so 4 out of 9 into, from the second bag we are taking 2 balls. Now both of them should be black, that's 7C2, right? Now we have to just simplify it. It's 5 into 3 into 7 by 9 into 10 C2 plus this is 4 into 7C2, right? So it's 5 threes are 15, 7s are 105 plus 4, 7C2 will be 7 into 6 by 2. So it's 21, 21 into 4 is 84 by 9 into 10 into 9 by 2. So that's 5, right? So it's 105 plus 84 by 81 into 5. We just have to simplify that. So it's 189 by 9 into 9 into 5. So it's 7 by 15, right? So do not forget to take both the cases. I hope you are clear. Now let's see this question. A bag contains 6 red and 5 blue balls and another bag contains 5 red and 8 blue balls. A ball is drawn from the first bag and without noticing its color is put in the second bag. A ball is then drawn from the second bag. Find the probability that the ball drawn is blue in color. Now further there are two cases. Let's discuss each case. Suppose in the first bag A, it's 6 red and 5 blue. In the bag B, there are 5 red and 8 blue. Okay, now what is the very first step? That's a ball is drawn from the first bag and we put it into the second bag without noticing its color. Now there are two choices, either the ball is red or blue, right? Now let's take the first case, maybe the ball is red. Now what is the probability of getting the ball as red is 6 by 11. Okay, now this is the probability of drawing a red ball from bag A. Now we are putting this red ball into bag B. Now in bag B there are 6 red and 8 blue balls. So in all there are 6 plus 8, 14 balls are there, and we have to draw a blue color ball, right? So what's the probability of a blue color ball? That's 8 by 14. So this is the probability when we are drawing red ball from bag A and putting it into bag B, right? The second case is, suppose the ball drawn from the first bag is blue. So that's the chances are by 5 by 14. Now this blue ball we are putting into the second, I'm sorry, this 11. in the second bag. So in all now there will be 14 balls, and since we are putting blue ball in this bag, so in all there will be 9 blue balls, and we have the favorable choice, that is to draw a blue ball. That's 9 by 14, right? So it's 11 into 14, and it's 48 plus 45, right? So 93 by 154 will be the correct answer. Okay, do not forget to take both the cases, like if the ball drawn or the ball which is shifted to this bag is red or blue, right? Now let's see this question. A combination lock on a suitcase has 3 wheels, each labeled with 9 digits from 1 to 9. If an opening combination is a particular sequence of 3 digits with no repeats, what's the probability of person guessing the right combination? Now, what will be the total number of cases? See, the 3 digits are different from each other, right? So how could we make so how many options we have from 1 to 9? See, we have 3 places. For the first place we have 9 choices, for the second place we have 8 choices, and for the third place we have 7 choices, right? So in all, 9 into 8 into 7, that's 504, right? So in all, the total number of combination will be 504, and there will be just a single combination that will be correct, right? So the probability of guessing the right combination will be 1 out of 504, right? This logic we have already discussed in our permutation combination session, so I hope you'll be cleared with this. Now friends, we'll be taking more problems in the next session. Do revise this session and the previous sessions as well. Bye bye.